here we are. I know I should have a mask on me, but let's see. So I'm gonna add soldering to all this. Can you see what I'm doing? Go, 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 go. I want to make a big, thick channel of soldering because I want more energy to pass through these things, these trails. Okay. It also cannot be too tall, otherwise it can short circuit the board with the case. Oh yeah, they're closing the building in 1 hour. That's a manual modification, let's say. Many controllers, they are adjusted by software. This one is analogical. So this is like a generic controller. So yeah, this is one of the ways of making it more powerful. And I could also replace the capacitors in case I'm gonna use a higher voltage battery, but this is not the case. I just want more current, and I like the way that's going here. Everything's going well. Yeah, perfect. Let's have a look how it is. Yeah, I may do just a bit on this corner and the other thing here as well. Okay, key. Yeah, in there. Speaking a bit of Portuguese. That's alright. Yeah, when I speak many languages, get confused. Okay, so full of soldering. Great. Now I'm gonna do this main trail. This one is very shallow, very shiny, but not so shiny, but yeah, very shallow. So I'm gonna add on this main area here. So start here, heating up. Great. Now every time when you are soldering, you have to be sure the two parts that you wanna put together, that they are hot. They have to be hot, otherwise the soldering will not bond. Okay, that's cool. I like the way it's going. It's like a manual job, you know. Bit tricky. This smoke is very toxic. Should have an exhaust here. Let me bring the exhaust. I got a fan. Put the fan blowing down up, and it's gonna be all right. Yeah. Don't know if it's gonna come on my face, but I have a mask, but I'm not finding it. Check this out. Oh no, it's so cool here. Let's see how it's going. Wow. Here I committed a crime. Why? I have to add soldering in a way that it will not touch the other side of the MOSFET. So I don't know if you guys can see what I'm doing. Yeah, so I open a gap. Perfect. Yeah, so there's a gap right here between the two MOSFETs. That's great, I like it. That's how we play the game. Okay. And what we are looking for, we are looking to increase like 3, maybe 4 amps, you know. So we are gonna add about 150 watts to the e-bike, which in terms of power doesn't seem much, you know. Say, ah, mate, you're gonna just add like 0.20 a few horsepower. Yeah, but in terms of torque, I'm gonna add a lot because I'm not changing the speed of the motor. I'm changing how much torque it's gonna have. So in terms of acceleration and hill climbing, it's gonna be a noticeable. You're gonna notice clearly the difference in power. And that's what we are looking for, you know. I used to tell my friends, every internal combustion engine dreamed to be an electric motor, because electric motors, they have high current, which means like high torque at low revs. So high torque at low revs, that's what a petrol engine, diesel engine would like to have. You can see a petrol car internal combustion engine, it's always idling at a very high revolution, you know, and just to keep the motor going. So electric motors don't need that. And as soon as you throttle, of course, depends on the configuration of the controller, but as soon as you throttle, you should have torque coming up straight away. Okay, I like what I see. I'm happy. Just making it look good. Okay. What else? Yeah, over there, beautiful, beautiful, beautiful. Now we have the last bridges between the MOSFETs and the phase, and that's where we are gonna play now. Okay, you like the song playing on the background? That's Sticky Fingers. It's a band from Australia. Really nice. The guys play really well. I like them very much, even though I'm a bit old now for those songs. But it reminds me a few years ago, when I arrived in Australia and I was a student and was doing crazy shit, just reducing the fan, the speed. And let's add a bit more soldering here as well, make it look good. If you guys don't know Australia, I recommend you to come to this country. It's an awesome country, multicultural, lots of freedom. You know, the police is cool. You guys are awesome. Even though when robbers steal our bikes, you know, they don't do much, but they treat you really well, different than in Brazil. You know, when you are treated like a criminal all the time, you know, and I understand why, you know, too much violence and things like that. Here, the police officers, they are really cool. Anyway, let's get back to this. This is the last bridge between MOSFETs and the phase. I'm gonna add soldering, more soldering, make it look good. Wow, I think this is a great outcome. So on this side we have the negative of the board. I'm gonna also add more soldering over there and one more final piece in here, and I think it's capable of delivering all the power I want. Then I'm gonna flip the board and we are gonna work on the shunt. Okay, that thing's done. This is done. Now I'm gonna Add more here, here, here. Keep going, more power. Do you guys know Bruno Power? Power! He's awesome, awesome guy. I like him very much. Pretty clever. I've been doing a few things together. He's a nice person. You should follow him. One of the best EV technicians in Australia. One of the coolest in the world. Bruno Power. Okay. Full of soldering. Nothing sticking out too much. You can see the results. Wow, tick. Hey, malak. Yeah, that's it. So now let's work on the shunt. I don't know if I can measure the resistance on the shunt before and after, but I'm gonna multimeter, kilo ohms, milliohms. Let's see what I can do here. Actually, that's this is just ohms. So let's see how many ohms. Yeah, it won't go kilo ohms. Yeah, it's it's kind of short circuit. Anyway, I'm unsure now how to measure the resistance of that shunt. But what I know how to do is let's add soldering in it and reduce the resistance. The more soldering we add, the less resistance it will get. Maybe the resistance is so small that I could not catch it with my multimeter, even though this is a fluke multimeter, but I played with range, or I don't know why. If someone knows, please help me. We are always looking for knowledge. Okay. So I added more soldering on the base of the shunt, and now I cover the shunt with soldering. I think this is more than enough. I'm gonna show you guys, and this negative wire I'm gonna mend it with the shunt to make a strong bond, but so I think this is more than enough for what I want from like previous experience. What's the problem? Adding too much power. If you remove the shunt completely, in terms of like making a bridge with very, very, very low resistance, you add too much power to the circuit board, and then the MOSFETs will burn, or the trails will kaboom, or the CMD, the small electronics, can kaboom as well. Okay, I'm gonna put heat sink paste we use on processors, between the computer processor and the heat sink. We add a thermal paste. I'm gonna get a thermal paste, apply here, and we can close the here I am, thermal paste. This one I bought in China when I was living in China. Opa, you know, stay there. So here we go, just checking how it's built. So every time we have this is the housing, we have the holes in here, and then the MOSFETs, they go attached like this. What I'm seeing, I'm looking for any contact between the bottom parts and the case. So I'm gonna take a small file. I'm just gonna remove some tips, some edges, just to prevent any contact. Now it's cool. Usually people don't like filing the soldering because this is lead, you know, powdering lead everywhere, and oh yeah, that's true, maybe. So what I'm gonna do, this gaffer tape is a very thick, like a tape with fiber. So I'm gonna take a piece of this tape and I'm gonna place inside of the controller. And I lower it down as much as I could. Okay, so I'm making a nice insulation between the housing. See what I'm doing? And the added soldering I placed. Now, you just have to be sure it's not gonna be on the way of the circuit board. See, yeah, no problems, no problems. All the wires getting in. Remember, wires, they have to be treated with care. Wires are like women, you know, unless you know the wires you are dealing with. Okay, so it's really cool. Okay, we have like a little mattress of tape, so it won't short circuit. And I'm gonna place the thermal paste, and I will remove this excess tape. Wow. I'm wild. Just by pulling the tape, I could bang. Yeah, this is really cool. You can also use a scissors. Modify it. Here we modify everything. We don't like it. We like going. Okay, so I'm gonna place paste on the bolts and on the plate, the heat sink. So when we squeeze it back to the controller case, we ensure we pass all the heat to the case, and because we have more current, it's gonna, yeah, maybe too much, not too much. Let's try it. I don't know everything. I don't know everything. I know only a few things. Okay, so this is this. It's gonna go like that. Okay, I'm gonna push it. I'm forcing, like, against. I'm keeping some room between the heat sink of the controller and the controller case. Why? Because can you see the excess of thermal paste? Yeah. If I keep this really close as I'm sliding, I'm gonna remove the thermal paste from the heatsink on the controller. Get my screwdriver, my Phillips. find the bolts, the holes actually. Alright, the holes are in there. Okay. It's like a delicate work. So I found the first hole. It will facilitate. Okay. I don't tie too much. I will find the other holes first before I start tightening. Even I will release one of these sides. Okay, that's cool. Start tightening the other. Get the other bolt. Where's the other bolt? Where's the other bolt? Yeah. Okay. There. Okay, so now I have all the field effective transistors and the heat sinks attached to the case, and they are properly tightened. Yeah, check this out. It's really cool. Okay, really cool, really cool. Very tightened. Lots of thermal paste, you know. The shunt is right there, completely modified. I'm gonna place this zero lid and its gasket on top. You know, what's the drawback of doing this modification? You can burn the controller, you can damage the motor, and if it's too powerful, which it won't, you know. The cars, they get out of factory with 600 horsepower and they are street legal. Okay, so the maximum power we would produce here would be like 1 horsepower, you know, so like 750 watts, something like that. Okay, so I'm closing this lid. So yeah, could burn the controller, could burn the motor. The battery is gonna be fine unless we short circuit the controller inside somehow, and then it could burn the BMS or eventually put fire in the system, you know, but that's a very extreme case, which it's like a thunder stroke, you know. You walk out in the rain and you get struck by a thunder, you know. So I don't think that's the case. And okay, so let's do it here. Closing the other side. Pretty happy with the modification, especially because I'm recording it for you guys, you know, those who want to play with analog controllers. Maybe that's the way to modify without having to buy a new one, you know. And if you know more about it, please comment below, because I'm happy to learn new things as well. Okay, so it's closed, it's tightened, all the sides are pretty closed. What I'm gonna do, I have to do the wiring of it on the bike, especially the battery wires. Okay, so I still have 20 minutes to work on this bike. I'm gonna pause the video, I'm gonna do the wiring, and then I come back again.